So, but MoleBook Notes, I think, is one of those sort of quite curious things. It's almost about trying to think about how to think about questions. And I think the best approach is to always have a sort of idea or thinking. It's called mole calculation. So there's going to be a mole calculation. And the other thing is there's probably going to be a ratio involved. So what I would suggest you write in your books is write down the equations you know. There are concentration of solid equations and concentration of solution equations. If we learn one version, moles is mass divided by mass of 1 mole, we can work out from this all possible arrangements of this. The other thing also, you can also use a magic triangle. MR, mass of 1 mole, is equal to mass divided by moles. So we could always do that. Mass is obviously going to be in grams. MR, as in mass of 1 mole, has units. It's relative, so we can ignore that. Or you could also think it's grams per mole. Now, the other equation, if we've got solutions, concentration is moles over volume. C equals N, which sometimes is used as a shorthand for number of moles. V for volume. Again, we can rearrange it into its two different forms. Now, my strategy is write down both mole equations, or 2 above. Mass is moles times MR, and concentration is moles over volume. Tick what you know and highlight what you need to find out. If an equation is given, it probably means there's going to be a ratio to work out. And most questions will lead you through the steps. So let's try doing this and applying this strategy. If we look at the question, it talks about sodium hydroxide and sulfuric acid. It's also got an equation, so there's going to be at some point in time a ratio. It's involving solutions, so I would suggest we write the equation down involving solutions. Concentration is moles over volume, and we've got 2 different solutions, so we could apply this concentration is moles over volume to 2 different things. One for the H2SO4 and one for the NaOH. Now, for the sulfuric acid, we've got a concentration and a volume. So we've got a concentration and a volume. So therefore, we could obviously work out the number of moles of sulfuric acid. So moles is equal to concentration times volume. Concentration 0.1 times volume, decimeters cubed, so 500 over 1,000, giving us 0.05. Now, to go from here to here, if you look at the equation, for every mole of sulfuric acid, we need 2 moles of sodium hydroxide. So the number of moles of this, we can work this one out, and this is going to have a value of 0.1. This is because obviously if we think about it, we could obviously write here 1 H2SO4 to 2 NaOH. So it's just the idea of this to this is the idea is the ratio between sulfuric acid and sodium hydroxide. In the question, it tells us the volume of sodium hydroxide, and it's asking us for concentration. So the volume is given in the question, 250 divided by 1,000. So this will give us a value of 0.4 moles per decimeter cubed. So we're going to go through some more examples of this and see if this strategy works. So on the examples, I started off just at the top of the sheet, just writing out all the equations again. And I did just go through the question about the reaction between sodium hydroxide and sulfuric acid and trying to sort of think about what steps are actually present with actually carrying this out. But what I think would be better is to actually, again, just try to apply it to some questions. So in this question, it says we have 1.4 grams of lithium nitrate and asks how many moles are present. So this is to do with a solid. So we know moles equals mass over mR. So it gives us a mass, MR, we can calculate it, so we can work out the number of moles. MR will be equal to, and this is where we use our periodic table, 3 lots of lithium, so 3 times 7 plus 14 will give us a mass of lithium nitride, giving us a mass of 35 grams per mole. So we can now type this in to our thing, 1.4 divided by 35, and hopefully this will give us a nice number, which always usually gives us an indication we're heading along our right sort of lines at GCSE. So 0.04. Now the next thing is when it says it's added to water, and again when it's added to water, it forms how many moles of lithium hydroxide. Again, if we look at our equation, here's lithium nitride and here's lithium hydroxide. So if we have, again, 1 lithium nitride, it will form 3 moles of lithium hydroxide. So you have 0.04 moles of this, it will form 0.12 moles of lithium hydroxide, so 0.12. Now, we could even sometimes help ourselves and say 0.12 moles of LiOH. And the reason we do that is it means that we sort of keep track of what we've got. It now says in the question, the volume of 0.5 molar sulfuric acid required to neutralize the lithium hydroxide calculated above is what, and some units. So we've just worked out we've got 0.12 moles of lithium hydroxide. So moles of sulfuric acid, we've got a ratio here of 2 to 1, which obviously isn't written. So 0.06 moles of sulfuric acid. So in the question I see the word volume, so I think I might need the equation concentration is moles over volume. It's asking me about the volume, so I can put a mystery mark there. Concentration 0.5 moles per decimeter cubed. I know the concentration, and from a previous bit, I know the number of moles, so I can do volume is equal to N over C. So number of moles 0.06 divided by a concentration of 0.5. Now I'm going to, obviously you don't normally write units in this, but if you think about this, this is units of moles. Units of concentrations are moles per decimeter cubed. So we've got volumes, units of moles cancelling out, and we're going to get an answer with values of decimeters cubed. So we do this calculation, we get an answer of 0.12 dm cubed. And if we times it by 1,000, we get it into centimeters cubed, so 120 cm cubed. Example 3. So 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. Let's see what the information gives us: a volume of sodium hydroxide and a concentration. So if we're given a volume and a concentration, we can work out the number of moles. Again, N, let's go through a step-by-step approach. Concentration is moles over volume, gives us a volume, gives us a concentration, so we can work out number of moles. Number of moles is C times V. Concentration 0.3 times a volume, 200 divided by 1,000, give us our number of moles of sodium hydroxide. So 0.06. Again, you see what I was saying, you would do a sort of mole calculation first, then there's something about ratios. So again, 2 NaOH to 1 H2SO4. We have got 0.06 moles of this. So the moles of sulfuric acid, we half this, so 0.03. 0.03. Calculate the mass in grams of this. If we do the MR of sodium hydroxide, sulfuric acid, 2 plus 32 plus 16 times 4, I think it's 98, let's check. 2 plus 32 plus 16 times 4 gives us a mass of 98 grams per mole. So what's a mass of sulfuric acid? Again, if we write our equation, moles, this is to do with solids, so moles equals mass divided by mass of 1 mole slash mR. We know that. We know the number of moles. So the mass here would be equal to, if I just rewrite it, mass is equal to N times mR. So this is going to be 0.03 times by 98 times 0.03, giving me 2.98 grams. I've done alternative ending just to show that sometimes it could be different. It said sulfuric acid has a concentration of this. What volume of solution would be required? We know concentration is moles over volume. It tells us about the concentration. We just calculated up here the number of moles. So we can say volume is equal to N over C. So 0.03, concentration 0.4. So 0.03 divided by 0.4. That gives an answer in decimeters cubed, which is equal to 0.075 dm cubed. So obviously if we want to write it into centimeters cubed, we'll multiply that by 1,000, giving us 75 cm cubed. Example 4 gives me a volume of sulfuric acid, a concentration of sulfuric acid. So volume and concentration, I can work out a number of moles for it. For the lithium hydroxide, it gives me a volume. So I've just highlighted the information here on the question. It says calculate the number of moles in 25 centimeters cubed of 0.107 moles of sulfuric acid. Again, concentration equals moles divided by volume. Therefore, number of moles is concentration times volume. Concentration 0.107 times 25 over 1,000 gives us an answer. So 0.107 times 25 over 1,000. You can see today they're obviously not been quite as nice for numbers. So 2.675 times 10 to minus 3. So we've done a mole calculation. Probably going to be a ratio now. So number of moles of this, because obviously this 25 centimeters cubed reacted with this volume of lithium hydroxide. So number of moles, again, if we look at the ratio, 2 LiOH. For every sort of mole of sulfuric acid, we need 2 moles of lithium hydroxide. So we can do 2.675 times 10 to minus 3, multiply it by 2. So 5.35 times 10 to minus 3 moles of LiOH. Now concentration, if it's concentration, concentration is moles over volume. We've just worked out the number of moles, 5.35 times 10 to minus 3. The volume was given as 22.85. If anyone's not sure where that came from, that was just from there. And we've got volume in centimeters cubed, so it's important to always remember anything to do with volumes, probably going to be something to do with times or divide by 1,000. So divide by 22.85 times by 1,000 gives me a concentration of 0.234 moles per decimeter cubed. If I just look at the values here, these are 3 sig figs, that's 3 sig figs. So the one with least accuracy is 3 sig figs, which is why I'm giving my answer here to 3 significant figures. As a general rule, I'd say give your answer to 2 sig figs at least. So deduce the amount of each one needed to form 0.15 moles of lead sulfate. So let's find our lead sulfate. Here's our lead sulfate. So if we look here, to form lead sulfate, we need the same amount of each, so 0.150 and 0.150 moles of that. Again, it's only worth 1 mark, so that suggests it's right. Volume, if I see the word volume, I can see that. I also see this, and I can go concentration, and I can go N to go number of moles. So volume, I go concentration is moles over volume. Rearrange this equation to go volume is moles over concentration. Next thing, if I'm trying to form, and it's now the question is talking about lead nitrate, we've just worked up here to form 0.15 moles of lead sulfate. We need 0.15 moles of lead nitrate. So number of moles is 0.150. Concentration given here was telling us was 0.5. And this is obviously going to give me an answer in decimeters cubed. So I'm going to put times by 1,000 just to do that. I would imagine either answer would be fine as long as you make sure you put units in there. So 0.15 divided by 0.5 times by 1,000, giving me 300 cm cubed or 0.3 dm cubed. So sulfur dioxide is used as a preservative in wine. Sulfur content can be found out by titration, so that's where you're mixing two different solutions together. It says in the question, they found 25 centimeters cubed sample of wine reacted with 15 centimeters cubed of iodine. So let's see if we can find the iodine here. So we can find the iodine. It's very nice. It's posted out the information or taken out the information again, so we can work out number of moles. We've got a volume. We've also got a concentration. So number of moles is C times V. So 0.0010 times by 15. Obviously it's in centimeters cubed, so we need to do divided by 1,000 to get our answer. So 0.001 times 15 over 1,000 gives me 1.5 times 10 to the minus 5. Now, how many moles of sulfur dioxide are present? If we look at the equation, if this amount of iodine reacted from the equation, if we have this many moles of iodine, same number of sulfur dioxide would have reacted. So 1.5 times 10 to the minus 5. Now talks about the concentration of the sulfur dioxide. Concentration, moles over volume. We've got the number of moles, 1.5 times 10 to the minus 5. Volume, let's find it here. It's a bit in pinky purple. Volume is 25. So divide by 25 times 5,000 gives us a concentration of 6 times 10 to the minus 4, and it's probably worth giving units, moles per decimeters cubed. Now, next bit says, so let's make a metaphor by the way. Okay, the next bit says calculation in grams per decimeter cubed. Well, what does this actually mean? So again, this is just trying to check your understanding. It means in 1 dm cubed, there are 6 times 10 to the minus 4 moles of SO2. So we've got moles, and we need to now work out the mass. So mass equals MR times number of moles. So the MR of sulfur dioxide, 32 plus 16 times 2 times number of moles, 6 times 10 to the minus 4, giving me, times 64, giving me a very small mass of 0.0384 grams. Now, again, if we just look at the data, some of the data is two significant figures. So I think an answer of two significant figures or three significant figures is fine. Now, the next bit is, again, this is just really trying to talk about a bit like application of science here. It says a solution greater than 16.16 grams per decimeter cubed makes wine unpleasant to drink. Is the wine drinkable? I've just worked out, the graph mass here in 1 decimeter cubed, so that's per decimeter cubed. So I should also make sure I put /dm cubed, which is bigger, this one or this one. The value is smaller than this value, so we can say wine is drinkable as calculated value less than 0.16 grams per dm cubed. I do hope that was helpful. Do please email me with a question so that we can keep on going on here and building up everyone's understanding.